What's up, guys, and welcome back to another Tenfold Live. My name is Philippa, and I'm here to bring you another episode proudly brought to you by Liberty. Over the next 3 terms, we're going to be covering over 100 episodes focused on maths and science to help you crush your matric examinations. So stay tuned every Monday to Thursday from 5 to 6 p.m. Also, remember, guys, that we've pre-packaged some great content to prepare you for this show, and that starts at 4 every Monday to Thursday. So stay tuned for that stuff, watch that in preparation for our show, and send in your questions for our live show. We'd love to respond to your stuff. Hit us up on our WhatsApp, our Facebook, even send us some shout-out videos. We'd love to see what you guys are dealing with in your matric. Anyway, if you feel like our show isn't giving you just that bit of edge that you need, download our Tenfold Education app, also brought to you by Liberty. It's such a fantastic app, guys. We've compiled some example videos, concept videos, even videos that show you how your matric maths is applied outside your classroom. Today is the last day of 2D and 3D trigonometry, so we're going to be taking some of those questions. But remember, next week we're doing factoring polynomials. So send in those questions, guys. We have some great prizes for you if we feature you on our show. So send in your questions, factoring polynomials. We'd love to help you out. For now, we're going to go into an introduction video on trigonometry, and then I'll be back to take your next question, so stay tuned.
Trigonometry is used extensively in many different fields. It is a branch of mathematics that is not only useful but fascinating too. Trigonometry improves critical thinking, geometrical reasoning, and problem-solving abilities. In the 2D and 3D trigonometry module, we take you back to the basics with revision of similar triangles and ratios, trigonometric ratios, special angles, solving triangles, finding angles, defining trig ratios on the Cartesian plane, the cast diagram, reduction formulae, trigonometric identities, and general solution. To be successful at 3D trigonometry problem solving, you will need to understand the concepts of solving triangles using 2D trigonometry principles and solving triangles using 3D trigonometry principles. Trigonometry is roughly 40 plus minus 3 marks in the final exam, which is approximately 27% of Maths Paper 2.
Hey guys, so hopefully that video has helped you orientate yourself within this episode. Right now we're going to take the first question, and it's sent to us from Koketso, so let's see what he wants us to do.
Hi Tenfold, my name is Koketso from Thompsonville. I have a mathematical question that I'm really struggling with. I really need help with this question, and I will appreciate your help. Thank you.
Alrighty guys, this is such a great question. I love it so much because it actually revises your geometric understanding as well. We've got a little bit of like characteristics of quadrilaterals. That goes back to grade 9, guys. So we're always testing constantly your maths knowledge. So let's jump into this question because it's really great. It says, E is the apex of a pyramid having a square base. Okay, immediately square base should scream things at you. Square base ABCD. O is the center of the base. Angle EBA is theta. AB, the side, measures 3 meters. And EO, the perpendicular height of the pyramid, is x. Okay, so indicate that that there is 90 degrees because it's perpendicular. First thing we need to do is calculate the length OB. Okay, so that's this length over here. Now, guys, remember, the moment you see square, you should remember there are so many characteristics of a square that you need to remember. Each side hits each other at 90 degrees, so the interior angles of a square are 90 degrees. And also diagonals, guys, important stuff with diagonals. The diagonals of a square bisect each other, they cut each other in half at a 90-degree angle. So that's important when we come to trigonometry. 90 degrees means a lot of stuff. Okay, so let's look at this. OB, if we look at the square base here, we've got A, B, C, D, and then O in the middle there. Okay, so automatically we know that this is equal to this, is equal to that, that. Okay, we've also given that the sides are 3 meters of the square. So we're trying to find, whoa, I've ordered my things wrong. Okay, so that's C there, A, D is there, and B is here. Okay, so we're trying to find OB. Okay, well, if I look here, I've got a 90-degree triangle happening here. So I can simply use Pythag to find one of the diagonals and then divide it in half to find OB. So if I say the diagonal that has OB, which is DB, is equal to 3 squared plus 3 squared, which means that DB is equal to the square root of 9 plus 9, which is equal to root 18. And let me just double check on my calculator. Root 18 simplifies to 3 square root of 2. Okay, but that is of the whole diagonal. So now we need to divide that in half to get OB. So OB is equal to root 3 over 2, 3 root 2 over 2. Okay, so nice, easy application of your knowledge of squares. I want to move on to the next question immediately because it's a really great question. Okay, so now we found that OB over here is equal to 3 root 2 all over 2. So now it says show that cos of theta is equal to 3 over 2 multiplied by the square root of x squared plus 9 over 2. Okay, so if I look for cos of theta, I've got theta over here, which forms part of this big triangle here. Okay, but now we've also just found OB, which forms part of this triangle here. If we look here, we've got E, we've got the perpendicular height there, which is x, and B there. Okay, so I want to try and find this side here so I can work in that triangle that has theta in it. Okay, so I'm going to try and find EB. So easy stuff, guys. We found that this here is 3 root 2 over 2. So again, Pythag, EB squared is equal to x squared plus that whole side squared, all squared, which means that EB is equal to the square root of all of that. So we get the square root of x squared plus, if we square that out, we get 9 multiplied by 2 over 4, which simplifies to x squared plus 9 over 2. Okay, so over here, this triangle here, this big triangle EAB that we're working with, this side is equal to that root of x squared plus 9 over 4. But so is this side because it's a pyramid and all sides are equal to each other. Okay, so now we have this lovely triangle that contains theta. We have A, B, theta, this would be E. Both of that side was given to us as 3, and both of these sides are x squared plus 9 over 4. Okay, so now guys, we have two sides and an included angle. This is also equal to that there. Okay, so we're applying the cos rule, guys, because we have 3 sides and an included angle. Okay, so what exactly we're trying to find? Cos of theta. Okay, so here, if we look, this is the opposite side to that theta. So we say that AE squared is equal to AB squared, which was given to us as 3, plus EB squared, which is that whole root of x squared plus 9 over 4, all squared, minus the product of those two sides, root x squared plus 9 over 4, and that there is multiplied by cos of theta. Okay, so, well, let me check here. AE was given to us. We can substitute in here. AE we found is also that root of x squared plus 9 over 4 squared. Okay, so if I simplify this a bit, we have this on one side of the equation and on the other side, so those two cancel out. If we take this 3 to the other side, we get 9 is equal to, well, negative 9 is equal to negative 6 multiplied by x squared over plus 9 over 4 all square rooted multiplied by cos of theta. Okay, if we further isolate cos of theta, we divide by that entire thing, we get it's equal to 9 over 6 root of x squared plus 9 over 4, and that simplifies to 3 over 2 root of x squared plus 9 over 4, which is actually what we were trying to find in the first place. Okay, guys, so hopefully this has helped you apply a little bit of your geometric knowledge, your square characteristics, all of your trigonometry stuff. And for now, we're going to jump into an ad break. And after that, we will have Sibusisio taking the next question, so stay tuned.